Day everyone. So in behalf of the RT1, I am Ala Alisan starting our topic, which is the electronic structure and periodicity. So ang connection between the electronic configuration and periodic table kay importante sa pag-predict sa properties sa individual elements. Ang periodic table sab kay magamit pod sa pag-determine sa electronic configuration sa isa ka element. One thing pod, ang kaning electronic configuration and the distribution of electrons dito sa main energy level kay makakatabang sad sa pag-locate sa position sa element dito sa periodic table o makadetermine pod siya kung asa nga group o period to na belong ang element. So in this lesson, we will learn further the concept of electronic structure and periodicity, the arrangement of elements in the periodic table, and the physical and chemical properties of the elements.
Periods and group. The elements in the periodic table are arranged in series of vertical columns and horizontal rows. The vertical columns are called group. The elements belonging into the same group have similar properties. The groups are further divided into A and B subgroups, and A is divided as follows. Group 1A, alkali metals. Group 2A, alkaline earth metals. Group 3A, boron group. Group 4A, carbon group. Group 5A, nitrogen group. Group 6A, oxygen group. Group 7A, halogen group. Group 8A, noble gas. So, for example, kaning group 1A, maon ni siya ang lithium, sodium, potassium, rubidium, cesium, ug francium. The horizontal rows, which are designed by 1, 2, 3, 4, 5, 6, and 7, are called groups. The elements belonging to the same period have varying properties. Period 1 has two elements corresponding to the two electrons in the S sublevel. Period 2 and 3 have 8 elements corresponding to 8 electrons in the S and P sublevels. Period 4 and 5 have 18 elements corresponding to 18 electrons in the S, P, and D sublevel. Period 6 and 7 have 32 elements corresponding to 32 electrons in the S, P, D, and F sublevels. Classification of an element. The element in the periodic table can be classified as representative elements, noble gases, transition element, lanthanides, and actinides. 1. Representative elements, also known as main elements, are the elements in the S and P blocks of the periodic table, with the exception of the noble gas. These include elements in group A1 to group 7A. Representative elements are further classified into 7 groups, namely A. Hydrogen, B. Alkali metals consisting of lithium, sodium, potassium, rubidium, cesium, francium. C. Alkaline earth metals composed of elements in group 2A, beryllium, magnesium, calcium, strontium, barium, radium. D. Poor metals, which include metal elements in group 3A, 4A, 5A, 6A, and 7A. Aluminium, gallium, indium, thallium, tin, lead, bismuth, anantrium, flerovium, ananpentrium, and livermorium. E. Nonmetals, which includes carbon, nitrogen, oxygen, phosphorus, sulfur, selenium. F. Halogen composed of fluorine, chlorine, bromine, iodine, and non-septium.
The elements in the periodic table can be classified into three main categories, which is metals, non-metals, and metalloids. Number 1. Metals. The majority of elements in the periodic table are metals. They include alkali metals, group 1, alkaline earth metals, group 2, transition metals, groups 3 to 12, poor metals, also known as post-transition metals. Lantanides and actinides metals tend to have a properties such as high melting points, electrical conductivity, luster, and density. Points and malleability and ductility, the tactical laws or donate electrons to form positive ions. Number 2. Non-metals are located on the rightmost side of the periodic table. They include elements such as carbon, nitrogen, oxygen, phosphorus, sulfur, and selenium. Non-metals have properties such as lower melting points for electrical conductivity and brightness. They tend to gain or accept electrons to form negative ions. Metalloids are elements that lie along the borders between metals and non-metals. They exhibit properties of both metals and non-metals and can act as either electrons donor or receives. Some examples of metalloids are boron, silicon, germanium, arsenic, and antimony.
Classify each of the following as metal, non-metal, or metalloid. But before saying all the answers, I'll explain what is metal, non-metal, and metalloid. So, metal. Most metal have a shiny metallic luster and reflective surface. Non-metals are generally dull or non-reflective and do not have a metallic luster. Metalloids can have a metallic or non-metallic appearance depending on the element. So number 1, Si or silicon is a metalloid. Number 2, H or hydrogen is a diatomic non-metal. 3, Cu or copper, transition metals. 4, fluorine or F, diatomic non-metal. 5, Sb or antimony, metalloids. 6, U or uranium, actinides, metal. 7, K, potassium, alkali metals. 8, W, tungsten, transition metals. 9, Kr or krypton, noble gas, non-metal. 10, Bh or boron, transition metal. Position of the periodic elements in the periodic table. We can easily determine the position of every element through its electric configuration. The table shows the representation of the arrangement of electrons distributed among orbital shells and subshells, or the electron configuration. For example, H and Li are both located at the S block. So, nani siya sa periodic table of the elements. And dire kay maoy nakuha na S block, which is ang H of Li. Based sa akong nasabtan is wait. Base na kung nagsatan is nabase siya sa circle kung asa siya ibutang. So, for example, H, number 1. Ang 1S is meaning a nice group. Ay, hindi. Ang 1S kay, muna siya natawag na direlate na side sa 1, 2, 3, 4, 5, 6, 7, 8. Ganon. Which is muna siya. Pero ang tapad ano sa 1S is number 1 or number 2. Nga nabutang man siya sa number 1, which is diri sa left side siya sumoni. So H is considered diri sa taas. While ang Li is naa sa ubos sa H, which is diri. Nya, ang gi-circle man sa book is Li 2S1. So, diri na siya sa ubos sa sa H, which is sa left side sa niyang group 1. Kaya yung kanang 1 to gagmay is by group na ang pagpasabot. Based sa akong na-learn. Yes. So, number B example is C and Ci are located in the P block, which is diri. So, also, based sa akong nasabtan, like, circle Japan, C, which is 2P2. So, asas ni siya na belong. So, diri dapita. Diri ta magkuan. Nya, ang number ani is 2. So, sa left side ta magsugod ani. I think. Ano ba? Okay, lagi. So, sa left side ta magsugod. So, 1, 2. So, diri na siya na belong. Yes. Wala na siya na belong. While ang CI or C1 kay 3P5. So, sa group 3 ni siya, which is diri. Tas, nya number 5 man ni ang iyang number. So, group 5 dyan na siya, obviously. So, diri ta magsugod. 1, 2, 3, 4, 5. So, diri ni siya nabilong. So, yes. That's all. Now, finally, we can easily determine the element's position by using the electron configuration of every element. So, muna siya, ma'am. That's all. Thank you!
Today, I'm going to explain this topic in my own understanding. Occupied main energy level equal period number. The number of occupied main energy levels correspond to the period number. For example, there are element, period number, electronic configuration, distribution of electrons in the main energy level, and number of main energy level here. So, the first element there is lithium. The period number of lithium is 2. To find the electronic configuration for lithium is we need first to find the number of electrons. We can do that by looking at the atomic number of lithium. So we'll use a chart. So we'll start with the table. S holds up to 2. P holds up to 6. D holds up to 10. That gives us the 1s orbital. And S holds up to 2 electrons. So we'll put those 2 electrons there and we'll go down the next to that row, which is the 2s. We've already got 2 electrons in that 1s orbital. So to get the 3, we only need to put 1 in the 2s orbital. If you add those up, 2 plus 1, that gives us 3, which is how many electrons we have for lithium.
electronic configuration equal group number. So this is the sample table. Group numbers. In terms of electronic configuration, we can easily identify an element's group in this following. First, we identify electronic configuration. This is a method to find group, period block, and balancing. First, we need to focus the number of electrons. 1s, 2s, and 3s would have 2 electrons. 2p, 3p, 4p is a hold up of 6 electrons, and 3d is a hold up of 10 electrons. Add all the exponent. If we add all the exponents, the answer is 36. Next, the group numbers. Again, we can easily identify an element's group in this following. Next is the energy level. 3 neutrons, which means 3 protons and 3 electrons. So we can identify in this method. So in first layer, we have 2 electrons and 2 weight. Write the 2, and then in second layer, we have 1 point.
Electronic configuration of each element is decided by the Aufbau principle, which states that the electron fills orbital in order of increasing energy levels. That equation is the concept of electronic configuration has replaced the older concept of valency and valence electrons. It involves the specific arrangement of electrons in shell and subshell and subshells of Bohr atomic model. This model has been widely accepted, and according to it, each atom has shells with further subshells. The shells are labeled K, L, M, N, and so on, from the innermost to the outermost shell. Each shell has subshells that are named for the type of emission lines produced by different state of angular momentum. They stand for sharp, S, principal, P, diffuse, D, and fundamental, F. The subshell has a distinct shape and configuration in which the electrons move freely. Each shell and subshell have limitation on the amount of electrons. that it can carry the maximum electrons that can be carried by subshell. S is 2 by P is 6 by D is 10. And the F subshell can carry 14. This decided the electron capacity of the shells. The K shell contains a 1 sharp subshell, hence it carries 2 electrons. The L shell has 2 sharp and 2 principal and carry 8 electrons. The M shell contains 3 sharp, 3 principal and 3 diffuse and can carry 18 electrons. The N shell contains 4s, 4d, 4p and 4f. Can carry 32 electrons. Such an arrangement helps explain the periodic and periodic trends observed across the elements of the periodic table.
And that concludes our topic for today. We hope you learned something. Thank you and God bless.